Okay, so final talk. I'll try to keep it short and entertaining. Some of us have flights to take after this, so I probably won't be able to be as short as Eric was yesterday with his presentation. I have more than 4 slides, but well, I'll try to keep it to make it quick. So, QuantLib, Ipython Notebook, and Docker, which means I'm going to show how, well, it's not it's no big results or breakthroughs in technology. It's just how I put together a few cool toys that I've been playing with in the past few months or weeks or years, depending on which one is which. And well, just to show what came out of it and see if possibly you can build over it and use it in your own for your own entertainment. As I said, QuantLib, Ipython Notebook, and Docker. I will assume you are familiar with QuantLib. I won't ask you for any show of hands in this room. I'll just skip to the second one and go for Ipython Notebook, which is this one. A few of you might be familiar with this one, right? Quick show of hands. Who ever used Python Notebook? Okay, almost half the room. For the other half, this one is a nice piece of technology. Basically, it allows you to embed Python in a browser. It allows you to save not only Python scripts, but combinations of scripts and documentation and plots, whatever. Well, basically, it has a number of properties which are there, but well, I probably can show you interactively. This one is it's a notebook server, Ipython notebook server. It runs in a browser. Well, no, it displays in a browser. It runs as a server, of course. We have just a simple notebook here. You can have any number of those. You can save them, create new. Basically, just for a quick demonstration, as I said, you can mix Python code here, which is live, and the documentation. You can use headings, math formulas using LaTeX syntax. The main feature of the notebooks is interactivity. This is not just displayed Python code, this executes interactively. So for instance, this is that list comprehension. I can define functions and run them. Using some modules like matplotlib or others, it provides graphing capabilities in line. So you can do something like this. This way you can well, basically you can do something like mathematical notebooks, or you can mix explanation, documentation with actual code samples that can be run. And in this, there are people well, writing blog posts in this way. There are people attaching notebooks to papers they write. It's getting kind of traction in the scientific community. Also, especially with regard to the recent trend towards reproducible results, in which you not only you write the paper, but also you provide some code to reproduce the thing and the data. And what might come as a surprise to even to some that already used Ipython Notebook is that in recent versions, there are interactive capabilities. So for instance, I can do things like this live in the browser and see things change. So, as I said, a number of features which, as I said, interactive, self-documented because you add documentation in between the code. It can also render in different ways. It can be converted as HTML, as Markdown with the graphs that you produced embedded in the thing. As I said, people is using this to write blog posts to publish. Not only this, nowadays GitHub and Dropbox, for instance, have native display support for notebooks, which means that if you run a notebook, you save it with your results and your plots, and you save it on GitHub, then people going to your file on GitHub is going to see the notebook rendered. Well, it won't be interactive in that case. It will be the saved version, but you will see it rendered in the browser. I'm still calling it Ipython Notebook because that's the version that I'm still using on my computer. Actually, nowadays it's called the Jupyter Notebook. Because they managed to separate the main engine, as in display and rendering and stuff, from the running the actual Python code. This means that this Jupyter Python notebook now works with other languages as well, in particular with Julia, from which the first JU comes. And well, it's just additional possibilities for this. As I said, these features make it useful for interactive demos, reproducible resource, as I said. For instance, I used it to demonstrate features of QuantLib when I did some of my courses, and or to explain features of QuantLib, and also I've been using it to record a few screencasts that you might have seen or not. Well, I'm not connected to the net right here, so that well, that's the URL, but that's I mean, don't write it down, please. Just search for me on YouTube, and you're going to find those, which, by the way, are. Here you're going to find something like this. Basically, these are screencasts in which I record the screen of my computer while I go through a few of these notebooks and explain how they work and explain features of QuantLib. This recorded at home, well, usually when the kids are asleep to minimize ambient noise, and well, a bit of story time. I'm recording those at home on my home computer, which is a Mac, which means I have to put in the first try I had to put QuantLib on my Mac. That was the easy part in a way, and I also wanted to try to install the Python notebooks on my computer. Well, I ran into a few first-world problems, as they're called, meaning that, well, I started researching how to install a Python notebook on the Mac. Well, there are ways. They're kind of tricky. I found instructions, but they were a couple of different sites giving instructions, saying, okay, you install this, and then you install that, and download that. Wasn't that... I tried one of those, didn't work. Was kind of stumped to begin with. Well, this was the main problem. The second one was that, well, QuantLib is starting to take a while to compile, and to take some memory to compile, and even more so for the QuantLib Python. So I was able to do it on my machine, but it was starting to get a bit taxing. So what I did at first try was, okay, this is kind of difficult to install on a Mac. It's not that difficult to install, for instance, on an Ubuntu machine. You just go and write apt install Python notebook, gets all the dependencies and all the whatever, and you get it installed and working. I said, I'm going to use a virtual machine. I built an Ubuntu virtual machine on my Mac using VirtualBox or whatever I had, whatever virtualization software I had on the machine. It worked. QuantLib compiles fine on that machine. It worked. I think I did a screencast or two using this technique. I wasn't still fully satisfied. It worked, but it was still kind of heavy to run a full Ubuntu system. Well, it wasn't the full Ubuntu. It was a Lubuntu, which is a more lightweight, with less requirement in terms of resources, but it was still kind of taxing on the Mac. And moreover, if I wanted to change the version of the notebook or the operating system, well, mostly the operating system, because a new version of Ubuntu was coming out, it was kind of lengthy to make a new virtual machine. I could either update the old one or create a new virtual machine, but still it's a full installation process for the whole operating system. After a while, well, mostly because some colleagues of mine showed the thing to me, and because they were thinking about introducing it to work, well, I found that what became the third item in this presentation, which is Docker. Docker, who is familiar with Docker here? So 1, 2, well, less than Ipython Notebook, a few. Well, I've been chatting with some of you with it, yeah, so I know that at least someone in this room knows more about Docker than I do. But anyway, Docker is, in short, is a virtualization solution, but instead of building a full virtual machine, it uses virtualization capabilities, well, capabilities present in the latest kernels of Linux kernels, to build lightweight containers, which first, well, they have a number of nice properties. First, they start up in seconds. You don't have to launch. You start a virtual machine, you're basically starting a computer. So, as fast as it can be, it takes a while to initialize the system and everything and get up. Also, the virtual machine allocates disk size for itself, allocates memory for itself. Docker containers are still isolated. They don't stomp on each other's memory or on each other's disk. They are isolated in that respect. But they share the kernel with the host machine, and they share resources with the machine. They don't take a whole bunch of memory to use as a whole operating system. They just take whatever memory they need from the common pool, which is the memory of the host system. Which means instead of something like this, which is the structure for usual virtual machines, you have the infrastructure at the bottom, and then the virtualization software, and then the whole guest operating systems, and your applications on top of that running into the system. It's more something like this. So you have still your infrastructure, your host. Then you have the Docker engine on top, but then your libraries and application are using, through the Docker engine, are using the same resources that the operating system. They're using the same kernel. As I said, this means they start up in second, and they are very lightweight. How lightweight? Well, they had the Docker people had a challenge at one of the last, not the last one, which was very recently, I think the Docker conference before the last one. One of the founders of the company, through a challenge, basically he went to the podium and demonstrated running 500 web servers, 500 instances of a web server in 500 Docker containers on a Raspberry Pi. And it's really a challenge. Who can do better? Well, the winner of the challenge ran 2,500 web servers on a Raspberry Pi. So that's how lightweight they are. These open up a whole new bunch of possibilities. For instance, you want to combine different services. Let's say you want to build up an application by, okay, you want a Postgres instance for a relational database. Maybe you want also some kind of NoSQL database and a message queue to put stuff into it and then perform separate calculations. And maybe you're logging stuff from all of them and you want to see through Kibana or whatever. With this machinery, it makes sense to have each of those, the Postgres instance, the NoSQL instance, whatever it is, to run each of those in a separate container. So they are insulated, they just communicate through their TCP ports. You shield yourself from incompatibilities like, oh, okay, Postgres needs this version of this library, but this other tool needs an incompatible version. Doesn't matter. They are running. It's like they're running on different computers, so each one has its own environment. And then you can combine and report. There is technology that Docker is which I haven't looked into yet, that Docker is developing to make it easier to manage clusters of containers and making them communicate. So it looks very promising for a number of applications. Only glitch, this is native on Linux. On Mac and Windows, well, it's not really glitch. To run Docker, you start a slim virtual machine, Linux virtual machine, which is not as heavy and requirement as a full Ubuntu virtual machine, for instance. You run a slim virtual machine, you run the Docker engine in it, and the containers run into this virtual machine that you fire up. And as I said, these capabilities, I mean, sharing the kernel but insulating the process, this was built in the kernel. So these capabilities were actually available in some ways for years before Docker. Docker really showed up, showed on the radar in the last couple of years. But in these couple of years, it took the world literally by storm. People are using Docker everywhere because, well, it has a number of use cases. For instance, in StatPro, we are thinking about using it for instance, we have a continuous integration machine, so we run tests continuously, and then we kind of we checkpoint our environment, so we say, okay, this revision is fine, and then eventually we can put it through staging and production. With Docker, not only you can put the same version of your software, you can, for instance, build a container with your application. You can run your tests in the container, and then once you're satisfied that works, you deploy the very same image on staging and deployment. So you also take away the possibility that maybe the continuous integration, maybe the system libraries have gotten out of sync with the production server or the staging server or whatever. It's the same environment. It's an image that you just deploy and fire up. You want to, when you do the deployment, you don't have to take down your production environment, overwrite it with the new version, and then start it up again. You just download the new image, and then in seconds you you shut down the previous image that is running, and you turn up the new one. Even for development, you can once you have you can build a standard environment with Docker, and when you develop it, then you can run your tests locally on your machine inside that environment to see that the tests work in the same environment that is going to go on the continuous integration and eventually to production. As I said, these capabilities were available in the kernel in some way. Why did Docker had this success? Well, mostly because of the tools that it made available. Docker makes it very easy to work with this technology. In particular, I'll talk of two tools. One is, well, Docker files. Docker files are basically recipes to build Docker images. One way you can build this image, is to do it manually, which means you start from a bare Ubuntu installation, for instance, which the Docker people provide, a very basic one with very little things installed, basically the basic operating system and little tools. And then you can log in, you can fire up an instance of that image, you can open a shell in it, and then you can start installing things with the usual apt-get, you can install stuff, or you can download stuff, compile it, and install it. Once you're satisfied that your environment is built as you want it, you can checkpoint that environment, and which means you can create a new Docker image from the environment that you created, and from then you can fire up new instances and run them. But you cannot make it. You can make it automatic, which means instead of logging in and running commands, you can write Docker files. These provide, well, basically they are recipes for building your images. They are, well, there are a number of commands that you can use. For instance, you can specify, first thing, you specify that you're starting from the Ubuntu images based on the trusty, the 12.04 version. No, sorry, the 14.04 version, the latest longer-term support version. And from that, okay, you can say who is the maintainer of the image, and then you perform commands. You say, okay, run this apt-get update command that is going to download and install the essential tools for building. So, for instance, this is going to install GCC, support libraries, this kind of stuff. You can mix it with different commands. For instance, in this recipe, I use this recipe to download the latest version of Boost, compile it, and checkpoint an image, a Docker image, with the G++ compiler and the Boost libraries available, already installed as system libraries so that they can be used. And you can write those recipes and you can structure them in layers. So, for instance, with this recipe, I can get an image with Boost installed based on this one. So, for instance, I can start from Boost, well, that was for Trusty. I can do the same for other versions. Based on a Boost image, I can download QuantLib, compile it, install it, and then I can create a Docker image with QuantLib installed as a system library and ready to, meaning that, well, it's in user lib, and ready to be used, so you can include and link and do whatever with if you open a shell in this machine, or if you build one of your images based on this one. Second tool, just for I was forgetting just to have a figure that says how streamlined this makes the building Docker images. At work, where I have a good compiling machine, I mean one with 4 processors, I think, and lots of memory, whatever. I go from basic Ubuntu from scratch, so basic Ubuntu image, to Boost, QuantLib Python, and Ipython Notebook on top in half an hour. So I get the whole system built in that time. So this makes it very easy to build this environment. Still didn't fully solve the problem that my Mac at home was getting a bit didn't have quite so much resources to build the whole thing. The second tool that Docker provides is the Docker Hub. Basically, it's a public site, well, infrastructure, they provide an API, whatever. Well, basically it's a place where you can store and distribute images. There are lots of them at this time. There are a number of official repos that are hosted on the Docker Hub. There are official repos for Ubuntu, for other operating systems like CentOS, Fedora. There are Postgres. There are numbers, a few tens of applications that are hosted there as an official repository. There are hundreds of thousands of applications put there by people that build their own images, that experiment with applications or whatever, and put the images there. Chances are you'll find that if you want to experiment with some technology, some application, some technology that you have read about, chances are that you can find the Docker image with that installed, so you don't have to actually install it in your machine. You can just download that, start it up, and play with it. Case in point, this presentation software, it's one that I wanted to try out. It's called the Reveal.js. It's JavaScript and HTML based. Well, basically you write your slide. It's one that I wanted to try because basically you write your slide in a text file with some markup. It's like Markdown, something like this. And so it's easy to version, easy to take diffs and whatever. And then the software takes it, converts it into HTML. It has CSS styles and whatever for transition and presentation and whatever. I wanted to try it, so I started looking into it. So I went to the Reveal.js site and I started looking at its installation instruction. Okay, it's you can just read, you can just point your browser at local files, but if you want all the capabilities, it's better if you serve it from a web server. So you also have to install this Grant web servers, which is made for, which works with Reveal.js. I was reading this instruction. I said, wait a minute. I'm writing a talk about Docker. I went to the Docker Hub. I searched for Reveal.js. I found, I think, 3 or 4 people that had provided images for it. In minutes, I was up and running with the image, and I was just writing the slides and seeing them rendered in the browser. In fact, this very presentation is running inside Docker image. In particular, the one provided by this kind sir. Thank you. Okay, by now I think you're. Oh, and also this notebook that I've shown. This is also running inside a Docker container. And to make a long story short, well, I guess you're getting where this is going to go. On the Docker Hub, there are also a few images that I have uploaded. In particular, one with, well, as I said, the 2 that I've shown, the one with the Boost library, with the QuantLib libraries. There are also images with QuantLib Python installed, so you can start it up or open a Python shell and start using QuantLib. And one with Ipython Notebook and of course also the QuantLib module, the QuantLib Python module installed. That is what I'm using during my screencasts now. So I just on my Mac at home, I just pull the image from the Docker Hub, I fire it up, and I serve the notebooks from there, and then I record them on the Mac, which makes it kind of easy to do. Here is the software that does the manages Docker images on the Mac. You can see, for instance, here these are the containers actually currently installed. This is the QuantLib notebook. This is also available for Windows. It's kind of nice. It has a number of well, apart from facilities to stop, restart the thing, you can also open a command line interface if you want the full Docker commands. It shows you a preview of the thing. You can click on this link thing, and your browser will be open on the port that this image is serving. You can, if you want, because you want to keep your notebooks on your local machine, it's possible to, well, not only with this software, with Docker in general, it's possible to map folders on your directories on your machine to directories inside the container. So this is what is the summary of the volumes which are exported. You can map the things. So, for instance, this folder on my Mac maps to this folder on the server, and so this you can keep the scripts on your machine. You can edit them on your machine, but the changes are reflected in in the ones that are being served. And well, that's basically that it, I guess. You can try it yourself. As I said, the images are on the Docker Hub. Once you have Docker up and running on your system, you can just run these two. Well, this one is not entirely visible, but it's just two commands. With these two commands, with the first one, you download the image. With the second, you run it, and you have QuantLib notebooks, well, a notebook server with the QuantLib Python module running on your machine, and you can see from the browser. Where to go from here? Well, not that I don't have any particular big projects or vision for this one. It was more like, well, I wanted to share the fun. I mean, these are. It was nice to experiment and play with these two toys. They solved the problem of having a working server for me on my home machine. And well, I don't know. It might be a way to let people try out QuantLib, as in instead of downloading, installing, compiling, just download this image, then just log in and try to link your programs against it. Or with QuantLib Python, it's even easier. You just enter into Python and start typing commands and experimenting. Might be a way to let people try out QuantLib, some kind of QuantLib to go. I don't know, maybe. Well, the images are there. You can try to use them, experiment. If you end up with some cool uses for that, well, just let me know. You know how to reach me, and maybe something good will come out of it. Well, in the meantime, I would say thank you, and well, if there are questions, I'm here. I can take them. Or thank you.